Today I want to talk about the clean, hexagonal, and onion architectures that promise maintainable, scalable, and decoupled code. However, in my experience, I've seen many development teams applying these patterns and ending up with a bloated, over-engineered code base. In this video, I'll explain why this happens, and I also give you some guidelines and principles you can use in your design to avoid falling in this trap. Let's start. The core tenet of these architectures is the dependency rule, or dependency inversion principle, which states that our core business logic, the rules that make our application unique, should not depend on anything external, not the UI, not the infrastructure like the DB or the message broker, not some third-party library or framework. The result should be that we have the core logic easily testable, stable, and decoupled from any external agency. So, for instance, you should be able to swap your database from MySQL to MongoDB, or maybe change the framework from Spring to Quarkus without having to rewrite the core business logic. That's the goal. So, where does it go all wrong? The risk is that we forget that these are guidelines, not dogmas. While these tenets provide excellent guidance, they're not a one-size-fits-all template that you can apply dogmatically. We still need to use our judgment and problem-solving skills to understand what our applications really need. Without that thinking process and personal judgment, the result is always an over-engineered system. Now let me tell you a real story about a financial application I reviewed. The goal was very simple. The user inputs some data on a form, presses a button, and we should save it on a database. That's it. No complex business logic. So what happened? The team decided to use the hexagonal and clean architecture principles, and they started out with a 5-module architecture, which looked very reasonable at the time. So we had a set of adapters to deal with the UI, the HTTP RESTful API, and the database. And then we had the logic split between application rules and business rules, where the core domain of the application really exists. However, when you look at how the code evolved, that ballooned into at least 20 sets of classes to maintain. I actually simplified the scenario to make it fit in a single slide, but I think it still gives the idea. So if you look at this, you can see that each module has its own set of objects and services, and with the exception of the business logic, every layer must do some translation to communicate with other layers. All for a simple form submission. That meant that every time you needed to update that record, you needed to modify at least 20 classes. And on top of that, you needed to write the unit tests. In general, I found the code very difficult to navigate. It was really a frustrating experience. I want to clarify that the issue wasn't just the number of layers. It was that the layers themselves were empty. There was no logic to be found. They were just pass-throughs existing only to satisfy the architectural rules. And this created a mountain of incidental complexity that had no real business value. So, how do we avoid this trap? We need to change our mindset. First, we need to start with just enough architecture. So we begin with the simplest possible structure that solves the problem we have. The problem we have today, not tomorrow or in 100 years' time. And we need to resist that urge to add layers for problem we only anticipate might happen in the future. Because we need to remember it's much easier to add a layer when you need it than to remove one that is useless but tangled in your code base. The second point is that we need to embrace an iterative approach. So our architecture isn't set in stone. we can allow it to evolve. We let new layers and abstractions emerge organically as the application's complexity grows. This is just-in-time architecture, not just in case. Which brings me to the next point, that we need to treat each layer in our application as an investment. Each layer has a cost. We need to build it and we need also to maintain it in the long term. So, what's a good investment and what's a bad investment? Let me give you some guidelines. A layer is a good investment if it hides implementation details, especially from external clients, maybe other development teams. If it enforces critical business rules, and if it reduces the cognitive load, which means it makes our application easier to understand. And finally, if it has high cohesion, which means the classes within this layer collaborate closely. In other words, it does one thing really well. What's a bad investment? A layer that's just a pass-through with no logic, or if the logic is so tiny that it's just adding navigational complexity. It's also a bad investment if it leaks implementation details and if it breaks the dependency rule, because we still want that outer layers depend on inner layers, but not the reverse. So let's try to apply these principles by creating a simple product API through which we can save and retrieve product details. No complex business logic. Step 1, the simplest design we could create, is having just one product class that's used for both the API and the database. This is the fastest. The advantage is that we only modify one class whenever we deal with the product. Maybe we need to add a new field. And the disadvantage is that the API and database are tightly coupled. Now, this is a perfectly valid approach. In fact, if you use Java and Spring, you could achieve this using this Spring data REST library. It will do everything for you. So when should we use this approach? If we're working on a solo project, if this is just a proof of concept, maybe we are a startup that needs to move really fast, or in any scenario where we don't have external clients or users for our APIs, where we build the clients that connect with this API. This is a valid approach. Now, as soon as there are other teams or external customers that use the API, this approach breaks, and the tight coupling between the API and database is not anymore acceptable. This is where we can iterate and add a new layer to our architecture. So in this case, we can have a separate product API class and another product DBO class, which will be used for the database. These two classes could even have different fields. The advantage is now we can change them independently. The disadvantage is that every time we need to add or remove a field from the product, we need to touch two classes, and in addition, we need to translate between them, so we need a mapping layer. There is also a third step, where we apply the clean or hexagonal architecture in a strict sense. So we add a new object that is going to be used for the domain layer that has no dependency with the infrastructure or framework. In this case, the advantage is that the core logic of our application is decoupled from anything. But if we're not planning to change the database, like we don't plan to switch from MySQL to MongoDB or vice versa, and we don't plan to change the framework, so we're sticking with Spring, is there really a return on this investment? In my opinion, there isn't. It's just over-engineering. That said, there are other scenarios where adding an additional layer makes sense. And we can use the example of an order API, where a customer places an order and it kicks off a complex workflow. We need to check the inventory, process the payment, notify the logistics, update the product catalog, possibly send some notification. So this is a workflow that has multiple domains involved. And they are adding an orchestration or use cases layer makes perfect sense because this layer's job would be to manage the complexity of the workflow and isolate the logic of the orchestration from all the subdomains that could be handled by independent modules in a modulet, or they could be different microservices in a distributed architecture. Another important concept I want to drive home is that the principles of the clean, hexagonal, and onion architectures can be applied at the system level, not just at the application level. Which means that if you're decomposing your system into microservices, these microservices themselves represent layers. They are a strong form of abstraction. So, don't make the mistake of recreating the complex packaging you would have in a monolith inside a microservice. Keep the microservice as lean as possible. To give you a concrete example, rather than an adapter layer or package within a monolith, we could have one or more adapter microservices that bridge the integration paths between our system and some third-party system. The logistic example is very good because we might have a microservice responsible to manage logistics in our domain. And then we would have multiple adapters to support integration with multiple carriers like DHL, FedEx, or UPS. So let's summarize. Number one, we always challenge the dogmas. Architectural patterns are guidelines, not unbreakable laws. Always ask, why am I doing this? The other is that we start simple and we evolve. It's easier to add a layer when it's necessary than to remove a useless one that's already tangled in our application. And number three is that we need to treat layers as an investment. Every layer must provide more value than the complexity it adds. If you can name the benefit, you probably don't need it. Clean, hexagonal, and onion architectures are powerful tools, but like any powerful tool, they can be misused. By thinking in terms of trade-offs, value, and evolution, we can stop being architectural purists and start becoming pragmatic, effective engineers. I hope you enjoyed the video. As usual, help me out by subscribing, enable the notification bell, and share the video with your colleagues so that everyone can learn something new. Ciao!